Learn it fast, learn it smart, learn with us at Sofo. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from Sofo Learning. The topic for our discussion today is trigonometry. So let us start with defining the sides of a right triangle. Looking at this right triangle, we have three angles and three sides, of which this is the right angle 90 degrees. And the side opposite to this 90 degrees would be the hypotenuse. Alright, now let's focus on this particular angle. Alright, so if this was A, B, C, we're talking about angle B right here. Now, this side is the side that is opposite to this angle B, and this is the opposite side. And this is the adjacent side, or the side adjacent to or next to this particular angle, angle B. Adjacent side. Now I'm sure you can imagine that if we were to change the angle from B to A, then the designation changes. So if it is angle A, then this side would become the adjacent side and this side would become the opposite side. But let's continue to focus on this angle B and define some of these ratios. So just to recap, the side right opposite to the 90 degrees is the hypotenuse, and the side that is sitting opposite to the angle that we are focusing on is called the opposite side, and the side that is next to or adjacent to the angle that we are focusing on is called the adjacent side. Now there are 6 trigonometric ratios that we need to remember. The first one is called sine of the angle B. For now, let's call this angle theta, and this is opposite side by hypotenuse. Cos or cosine of this angle theta is this adjacent side by hypotenuse, and tangent or tan theta, and that would be opposite side by adjacent side. Alright, now the inverse of these ratios, so 1 by sine theta, 1 by cosine, and 1 by tan theta are also trigonometric ratios, and we will look at that next. The inverse of sine is called cosec theta, and that is 1 by sine theta, and that would be hypotenuse by the opposite side. The inverse of cosine is called sec, and that is 1 by cos theta, and that would be hypotenuse by the adjacent. And the inverse of tangent is cot or cotangent theta, that would be 1 by tan ratio, and that would be adjacent by the opposite side. So these form the 6 ratios that we need to remember, and we need to understand, and we need to assimilate. Next principle that we need to think about is that the angle determines the ratio. Even though the measurement of the ratio is the length of the side by length of the other side and things like that, angle is the determinant of the ratio. Now we will prove that using the principles of similarity of a triangle. I have created a triangle ABC. This is the 90-degree right angle, and we are focused on this particular angle theta right here. So I have created a second triangle within the original triangle ABC, PBM. Now, since this angle is a constant and this angle is a constant, this one is a perpendicular line and this is also 90 degrees. By the theories of similarity of these two triangles, right, we know that the triangle ABC and PBM are similar in nature, and therefore the sides are essentially proportional to each other. So the ratio of the sides are similar. You see, AB by PB is equal to CB by MB, and similarly this is equal to AC by PM. So if these angles are essentially proportional, the ratio between these angles, AC by AB and all of that, will not change when we talk about the big triangle or the small triangle, as long as this angle continues to be a constant. We can generate a relationship between the sine, the cos and the tan ratios, particularly sine and cos ratios, using the Pythagoras principle. Now, in order to demonstrate how that works, I have created a right triangle here with sides A, B and C. Alright, now let's just take this as the angle in question, theta. Now the Pythagoras theorem just states that a squared plus b squared is equal to c squared. Alright, so this is the Pythagoras theorem. This side, square root of this side plus this side is equal to the square of this side, essentially. Now let's just divide both sides by the hypotenuse squared. So c squared over here and c squared over here. What we get is a by c squared plus b by c squared is equal to 1. So this is essentially 1. This c squared goes into each of these terms, and I have taken the liberty to put that into brackets. So a by c is essentially the adjacent side by hypotenuse, which is the cos theta squared, plus b is the opposite side by hypotenuse, which makes it sine theta squared is equal to 1. So this is the fundamental relationship between the sine and the cos ratios of an angle. There is a relationship between sine, cos and tan. So tan theta is equal to sine by cos. Let me prove that to you. Alright, so tan is, from this triangle we have b by a. So this tan theta is opposite side by the adjacent side. Now we can utilize the sine ratio and the cos ratio to represent the b and the a. Let me show you. So if we were to do b by c divided by a by c, what we are going to get is fraction division involves multiplying by the inverse, right? So b by c multiplied by c by a, these two would cancel each other and you will get b by a. Alright, see, these two are essentially equal. Now this b by c, opposite side by hypotenuse, this is sine theta. So you get sine theta divided by, and this is a, or adjacent side by hypotenuse, and that is cos theta. So ultimately this is sine theta by cos theta. So remember these relationships between these ratios as well as the definition of these ratios. All right. Sine is opposite side by hypotenuse, cos is adjacent side by hypotenuse, and tan is opposite side by adjacent side. The relationship is sine squared plus cos squared is equal to 1, and tan is equal to sine by cos. Thank you for watching.